Hello everyone, welcome to my channel and Borate's Easy Study of Physics. Anyone can study physics with the help of this channel. Basic study of physics is important for all types of competitive exams like NEET, JEE, IIT. It is also important for engineering students. When basic concepts are clear, we can apply these for solving numericals, derivations, etc. Complete study of physics depends on four main basic points. These are measurements, scalars and vectors, study of motion, concept of fields, that is electric field, magnetic field and gravitational field. When we understand these basic concepts, the study of physics becomes very easy. I am going to explain you these concepts step by step in a very easy way. Before starting study, I request you please like, share and subscribe to this channel. First, we are going to study what are physical quantities. Physics is the science which deals with the study of nature and natural phenomena. For example, Earth rotates about its own axis. Also, it revolves around the sun. Moon revolves around the earth. Such an examples which are going to study in physics, which are we going to study in physics in the concept of gravitational field. In order to study these phenomena, we perform many experiments. While performing experiments, two things are important. These are observations and measurements of physical quantities. But what are these physical quantities? First, we are going to understand what are physical quantities. This is most important. Physics is the science of measurement. So, it is necessary to understand what is measurement and how physical quantities to be measured. We are going to study this most important basic concept of measurement. First point of this basic concept is to understand what are physical quantities. Let us consider one example of natural phenomenon. When we throw any object in the upward direction, it reaches to certain height and then returns on the earth's surface. In this example, we give velocity to the object on the earth's surface, that is kinetic energy. Due to this kinetic energy, it moves in the upward direction. During its motion in the upward direction, gravitational acceleration, which is directed in the downward direction, opposes the motion of object. Therefore, its velocity goes on decreasing. Its kinetic energy also goes on decreasing, but potential energy goes on increasing. When it reaches to certain height, its velocity becomes zero, kinetic energy becomes zero, but potential energy becomes maximum. As its upward velocity becomes zero, this object returns on the earth's surface. During its motion in the downward direction, its velocity goes on increasing because acceleration due to gravity and velocity both are in the same direction. Therefore, gravitational acceleration assists the velocity and velocity of object goes on increasing. Therefore, its kinetic energy also goes on increasing, but potential energy goes on decreasing because distance from the Earth's surface goes on decreasing. When it strikes the ground surface, its potential energy becomes zero, kinetic energy becomes maximum, and velocity becomes maximum. In this phenomenon, during upward motion, kinetic energy is converted into potential energy, and during downward motion, potential energy is converted into kinetic energy, because we know that energy cannot be created nor we can destroy it. It is converted from one form into another form. In this phenomenon, we have to measure velocity, acceleration, height, that is length, energy, that is kinetic energy and potential energy, time taken by the object to reach the certain height and to return on the earth's surface. These velocity, acceleration, height, energy, time are called physical quantities. How these quantities to be measured? What is the base of measurement? Let us study. For measurement, all physical quantities are classified into two groups. These are fundamental quantities and derived quantities. What are fundamental quantities? Physical quantities which do not depend on physical quantities which do not depend on any other quantity for their measurement are called fundamental physical quantities. For example, length, mass, time, temperature, electric current, luminous intensity, and amount of substance. Out of these seven fundamental quantities, three are most important. These quantities are measured directly with the help of instrument. For example, length is measured with the help of scale, mass is measured with the help of balance, time is measured with the help of clock, temperature is measured with the thermometer, electric current is measured with the help of ammeter. Luminous intensity is physical quantity which is used to express brightness, that is intensity of light. These quantities are directly measured, so they cannot require any formulae. Derived quantities. Physical quantities which depend on one or more fundamental quantities. Physical quantities which depend on one or more fundamental quantities for their measurement are called derived physical quantities. There are large number of derived physical quantities. For example, area, volume, velocity, acceleration, momentum, force, work, energy, etc. These quantities cannot be measured directly. These quantities require formulae for their measurement. Let's see some examples. When we find area of rectangle, we have to measure its length and breadth. Then using the relation area equal to length into breadth, we find area of rectangle. In this example, length is measured in meter and breadth is also measured in meter. For example, if the length is 3 meter and breadth is 2 meter, then area of rectangle is 3 meter into 2 meter, that is 6 meter square. Thus, the measurement of physical quantity area depends on fundamental quantity length. Second example, when we find volume of cube, we have to measure its length, breadth and height. Then using the relation volume equal to length into breadth into height, we find volume of cube. Thus, the measurement of volume of cube depends upon, measurement of volume depends upon which fundamental quantity? Which fundamental quantity? Length. Third example, density. Density equal to mass upon volume. Therefore, when we find volume of cube, we have to measure its mass and volume. Then using the relation density equal to mass upon volume, we find the density of cube. Thus, the measurement of physical quantity depends upon which fundamental quantities? Mass and length. There are large number of derived quantities. Some of them are explained here. Now the next point of measurement, next important point for measurement is units for measurement, which we discuss in the next lecture. Till then, goodbye.